there is one specific formula right now that everyone is doing. And this formula is train a larger and larger transformer on more and more data. I think maybe the most surprising thing for me is the whole thing works at all, It's hard. I'm not sure I know how to convey this, what I have in mind here, because if you see a lot of neural networks do amazing things, well, obviously neural networks is the thing that works. But I have witnessed personally what it's like to be in a world for many years where the neural networks don't work at all. And then to contrast that to where we are today, just the fact that they work and they do these amazing things. I think maybe the most surprising, if I had to pick one, it would be the fact that when I speak to it, I feel understood. The big way in which things are changing is that these models become more and more reliable. Before, they were only very partly there. Right now, they are mostly there, but there are still gaps. And in the future, perhaps, these models will be there even more. You could trust their answers. They'll be more reliable. They'll be able to do more tasks in general across the board. And then another thing that they will do is that they'll have deeper insight. As we train them, they gain more and more insight into the true nature of the human world. And their insight will continue to deepen. I would actually point out that the main thing that's lost when you switch to the smaller models is reliability. I would argue that at this point, it is reliability that's the biggest bottleneck. So certainly people who care about some specific application have every incentive to get the smallest model working well enough. I think that's true. It's undeniable. I think anyone who cares about a specific application will want the smallest model for it. That's self-evident. I do think, though, that as models continue to get larger and better, then they will unlock new and unprecedentedly valuable applications. So yeah, the small models will have their niche for the less interesting applications, which are still very useful. And then the bigger models will be delivering on applications. Let's pick an example. Consider the task of producing good legal advice. It's really valuable if you can really trust the answer. Maybe you need a much bigger model for it, but it justifies the cost. I do think that there will come a day where the level of capability of models will be very high. Like in the end of the day, intelligence is power, right? Right now, these models, their main impact, I would say, at least popular impact, has been primarily around entertainment and like simple question answer. So you talk to a model, wow, this is so cool. You produce some images, you had a conversation, maybe you had some question, you got answered. But it's very different from completing some large and complicated task like, well, what about if you had a model which could autonomously start and build a large tech company? I think if these models were open source, they would have a difficult to predict consequence. Like we are quite far from these models right now. And by quite far, I mean by I time scale, but still like this is not what we're talking about. But the day will come when you have models which can do science autonomously, like deliver on big science projects. And it becomes more complicated as to whether it is desirable that models of such power should be open sourced. I think the argument there is a lot less clear cut, a lot less straightforward compared to the current level models, which are very useful. And I think it's fantastic that the current level models have been built. So like that is maybe I answered a slightly bigger question rather than what is the role of open source models. It's like, what's the deal with open source? And the deal is up to a certain capability. It's great, but not difficult to imagine models sufficiently powerful, which will be built, where it becomes a lot less obvious as to the benefits of their open source. Like at this point, I don't think anyone doubts that the transformer architecture can do amazing things, but maybe something else, maybe some modification could have some compute efficiency benefits. So it's better to think about it in terms of compute efficiency rather than in terms of can it get there at all? I think at this point, the answer is obviously yes. To the question about, well, what about the human brain and with its brain regions? I actually think that the situation there is subtle and deceptive for the following reasons. So what I believe you alluded to is the fact that the human brain has known regions. It has a speech perception region, it has a speech production region, it has an image region, it has a face region, it's like all these regions. And it looks like it's specialized. But you know what's interesting? Sometimes there are cases where very young children have severe cases of epilepsy at a young age. And the only way they figured out how to treat such children is by removing half of their brain. Because it happens at such a young age, these children grow up to be pretty functional adults. And they have all the same brain regions, but they are somehow compressed onto one hemisphere. So maybe some, information processing efficiency is lost. It's a very traumatic thing to experience, but somehow all these brain regions rearrange themselves. There is another experiment which was done maybe 30 or 40 years ago on ferrets. So the ferret is a small animal. It's a pretty mean experiment. They took the optic nerve of the ferret, which comes from its eye, and attached it to its auditory cortex. So now the inputs from the eye starts to map to the speech processing area of the brain. And then they recorded different neurons after it had a few days of learning to see, and they found neurons in the auditory cortex which were very similar to the visual cortex. Or vice versa. It was either they mapped the eye to the ear, to the auditory cortex, or the ear to the visual cortex. But something like this has happened. These are fairly well-known ideas in AI, that the cortex of humans and animals are extremely uniform. And so that further supports you just need one big uniform architecture. So right now, those systems are clearly not autonomous. They're inching there, but they're not. And that makes them a lot less useful too, because you can't ask it, hey, do my homework or do my taxes, or you see what I mean? So the usefulness is greatly limited. As the usefulness increases, they will indeed become more like artificial life, which also makes it more, I would argue, trepidatious, right? Like if you imagine actual artificial life with brains that are smarter than humans, that seems pretty monumental.